Now today we will learn applications on derivatives in that exercise 2.2, which is based on the approximations. In that, the first example is find the approximate value of the given function as the required points, square root of 8.95. So here we have to choose the function as root x. Okay, and so the derivative of this f of x will be 1 upon 2 root x. Now I want to choose a point A and the small value h, so that their sum is 8.95, but at the same time I have to pay attention to the value A whose the square root I know and which is nearer to this 8.95. So obviously the value is 9, because the square root of 9 is 3 and I know it. So I have to take the h as minus 0.05, so that their addition gives us 8.95. So f of a is equal to square root of 9 is equal to 3, and f dash at a is equal to 1 upon 2 root 9 is equal to 1 upon 6. Now this is the formula to find the approximate value. F of a plus h is approximately equal to f of a plus h f dash at a. Therefore, root a plus h is approximately equal to 3 plus minus 0.05 into 1 by 6. Therefore, root 9 minus 0.05 is approximately equal to 3 minus 0.0833. So square root of 8.95, which comes out to be 2.99167. Now look at this next example. It's cube root of 28. So our function is obvious, a cube root of x. So its derivative is 1 upon 3, x raised to minus 2 by 3. How to find the derivative? This cube root of x, we can write it as x raised to 1 upon 3. That means it is in the form of x raised to n, and we can find its derivative by using the formula x raised to n. Its derivative is given by n times x raised to n minus 1. Now I want to choose the point A. Now I will choose the point which is nearer to 28. I want an integer which is nearer to 28 and whose cube root I know. So I must take A as 27, because it is the cube root of 27 is 3. So h is equal to 1, so that a plus h is 28. Now cube root of 27 is 3, so f of a is 3, and f dash at a is 1 upon 3 into 27 raised to minus 2 by 3. If you simplify this 27 raised to minus 2 by 3, you will get 1 upon 9. So 1 upon 9 into 1 upon 3 is 1 upon 27. Now use the formula of approximation. F of a plus h is approximately equal to f of a plus h f dash at a. So putting the values in this formula, you will get a cube root of 28 as 3.0374. This is the cube root. Now the next example, find the approximate value of fifth root of 31.98. So here my function will be fifth root of x, that is x raised to 1 upon 5. Now differentiate with respect to x. F dash of x is 1 upon 5 times 1 upon fifth root of x raised to 4. So here I will choose a is equal to 32 and h is equal to minus 0.02, because the fifth root of 32 is 2, which I know. So fifth root of 32 is 2, and f dash at a is equal to 2 is 1 upon 80. Okay, so the formula for approximation is f of a plus h is approximately equal to f of a plus h f dash at a. Therefore fifth root of 32 minus 0.02 is approximately equal to 2 plus minus 0.02. h is our minus 0.02, and what is f dash at a? It is 1 upon 80. So after simplifying, you will get the answer fifth root of 31.98, it approximately equal to 1.99975. Similar to these examples, now we have to find the approximate value of 3.97 bracket raised to 4. So that means f of x raised to 4. So its derivative is 4x cube. Now I want to choose an integer. So the best positive integer which is nearer to this 3.97 is 4. So I am choosing a is 4. So I must choose h is minus 0.03. So f of a is equal to 4 raised to 4 and is equal to 256. And f dash at a, that is f dash at x is equal to 4, is 4 into 4 cubed. It is also equal to 256. Use the approximation formula and put those values in this formula. You will get 3.97 bracket raised to 4 is approximately equal to 256 minus 0.03 into 256. The multiplication of these two numbers is 7.68. So we have to subtract this from 256. That is our answer. Fourth power of 3.97 is 248.32. Now find the approximate value of the given functions as 4.01. Again, here we will choose the function f of x is equal to x cube. We will choose a as 4 and h as 0.01. So using the formula, f of a plus h is approximately equal to f of a plus h f dash at a. Using these given values and the value of f of x at x is equal to a and f dash at x is equal to a, we get 4.01 raised to cube is approximately equal to 64 plus 0.01 into 48. Take their multiplication and take their addition. You will get the cube is approximately equal to 64.48. Now the next problem is related to the trigonometry. Sine 61 degree we want to find, and it is given that 1 degree is 0.0175 radian and the value of root 3 is 1.732. Here we don't have to what we can say, that we don't have to pay attention to the choosing of the function, because we have to choose directly sine x as it is given. The function sine of something is given, so we have to choose sine x. So f of x is equal to sine x, its derivative is cos x. So now we have to choose a as 60 degree and h is 1 degree, but 1 degree is 0.0175 radian. My sine 60 is root 3 by 2 and f dash at a, that means cos 60 is 1 upon 2. Now this is the formula for approximation. F of a plus h is approximately equal to f of a plus h f dash at a. So sine 60 degree plus 1 degree a plus h is approximately equal to root 3 by 2 plus 1 degree into 1 upon 2. But 1 degree is nothing but 0.0175. Okay, and the value of root 3 is also given 1.732. So we will put that values also. Then now here is also the denominator is 2 and in this case is also denominator 2. So we will take addition of the numerators only, and then finally we will divide the numerator by 2 to obtain the value of sine 61 degree, and it comes to be 0.8747. Similar to this previous example, sine 29 degree and 30 minutes. So 30 minutes is same as 0.5 degree. Okay, so this we have to, now I am choosing a as 30 degree because I don't know the sine 29 degree, but I know the value of sine 30 degree. So I will choose a as 30 degree and h is as minus 0.30 minus 30 minutes, that means minus 1 upon 2 degree. So f of a is sine 30 is half and f dash at a, that is cos 30, is root 3 by 2, and the value of approximation is the formula to find the approximate value. F of a plus h is approximately equal to f of a plus h f dash at a. Using the given values and simplification, you will get the answer 0.4924. The next example is tan 45 degree and 40 minutes. So here I have to choose a as 45 degree and h is 40 minutes, and 1 degree is 0.0175 radian. So 40 minutes is equal to 40 upon 60. So it come converted into the degrees. 40 minutes is same as 2 by 3 degree. So we are dividing 40 minutes by 60 to convert it into the degrees. So the next step, again here also tan of something is given, so our function must be tan x. Its derivative is sec square x. So approximations formula, use the given values in this formula and just goes on simplifying. Finally you will get the answer as tan of 45 degree and 40 minutes is approximately equal to 1.0233334. Similar to the previous one, cos of 60 degree and 30 minutes. So here we will take a as 60 degree and h as 30 minutes, that is 1 upon 2 degree, but 1 degree is 0.0175, so 30 minutes is equal to 1 upon 2 degree is same as 0.0175 upon 2 radian. So our function is cos x, so its derivative is minus sin x. We will find the value of this f of x and f dash of x at x is equal to 60 degree. Then using the formula for approximation, we will put those values in this formula and then just goes on simplifying it. After taking the multiplication of these two numbers, uh, 0.5 minus 0.0076, take their subtraction and you will get the cos of 60 degree and 30 minutes is approximately equal to 0.4924. Okay, now the next example is cos inverse of 0.999. So our function is cot inverse of x. Its derivative is minus 1 upon 1 plus x square, and here we have to choose x is equal to a is equal to 1 and h is equal to minus 0.001. So at this point x is equal a is equal to 1, we have to find f of x and f dash of x. Then using the formula for approximation, using the values, we will get cot inverse of 0.999 is approximately equal to 1 upon 4 into 22 by 7 plus 0.0005. So cot inverse of 0.999 is approximately equal to 0.78621. Now find the approximate value of tan inverse of 0.999. Just now we have find out the value of cot inverse of 0.999. So again on the same line, here the function is tan inverse of x and its derivative is 1 upon 1 plus x square. So put a is equal to 1 and h is equal to minus 0.001. So f dash at a is equal to 1 upon 1 plus 1 square is equal to 1 upon 2. So we know that f of a plus h is approximately equal to f of a plus h f dash at a. So tan inverse of 1 minus 0.001 is approximately equal to pi by 4 plus minus 0.001 into 1 upon 2. So tan inverse of 1 minus 0.001 is approximately equal to 1 upon 4 into 22 by 7 minus 0.0005. That is tan inverse of 0.999 is approximately equal to 0.78521. Now the next example, here we have to find the approximate value of e to the power 0.995, and it is given that e raised to 1 is 2.71828183. Now the obvious function is e raised to x. We don't have other choice to choose the function. So its derivative is again e raised to x is. Now here you have to choose a is 1 and h is minus 0.005. So we will find the value of f of x and f dash of x at x is equal to 1. That is at a is equal to 1. and it is e to the power 1, that is 2.71828183. Take the formula for approximation and put those values in this formula. Goes on simplifying, take their multiplication and addition, you will get e raised to 0.995 is approximately equal to 2.7046940034. Now you don't need to write. Sometimes it is already given in the example that find the approximate value up to 4 decimal places. So we will restrict our answer to 2.7046 only. And now here instead of 6, then I will write 7 because the next digit is greater than 5. Okay. If I ask to find the value of the given approximate value at 5 decimal places, then 2.7046 up to 9. Our last digit is 9. Now find the approximate value of tan inverse of 1.001. Now again the same, tan inverse of x, its derivative is 1 upon 1 plus x square, a is 1 and h is 0.001. Okay, take the formula for approximation and put those values in this formula and simplify it. You will get tan inverse of 1.001 as 0.78621. Now the next example is you have to approximate value of 3 raised to 2.01, and it is given that log of 3 is equal to 1.0986. Now here the function we have to choose is f of x is equal to 3 raised to x. Its derivative is 3 raised to x log of 3, and our a is 2 and h is 0.01. Now f of a means 3 square is 9. F dash at a is 3 square log of 3, but log of 3 is given 1.0986. Take their multiplication, you get 9.8874. Now f of a plus h is approximately equal to f of a plus h f dash at a. Put those values in this formula and goes on simplifying. 3 raised to 2.01 is approximately equal to 9.098874. E to the power 2.1. So here you have to choose f of x is e raised to x, f dash of x is e raised to x, a is equal to 2 and h is equal to 0.1. Just put the values in the approximate formula and you will get the answer. Now next example is interesting. Log of 9.01 to the base e, and it is given that log of 3 is 1.0986. Now here log of x to the base e, we have to choose the function as log of x to the base e, and its derivative is 1 upon x. Now we have to choose a is equal to 9 and the fractional part 01 is h. Then f of a is log of 9 to the base e. This 9 can be written as 3 square, and that square 2 will go in front of that log, so using index property. So 2 times log of 3 to the base e, but its value is given. Log of 3 to the base e is 1.0986. So we'll put that value, and after putting the value, we will multiply it by 2. And f dash at a is 1 upon 9. The formula to find the approximate value is f of a plus h is approximately equal to f of a plus h f dash at a. So using the values in this formula, take their multiplication with the 2 decimal points will be shifted to this left side. Take their addition. So log of 9.01 to the base e is approximately equal to 2.1985111. Okay, so this is the approximate value of log of 9.01 to the base e. E is the natural base, natural logarithm. Now log of 101 to the base e, again same. Here we have to again choose our function f of x is equal to log of x to the base e. So derivative is 1 upon x. A is 100 and h is 1. So log of 100 to the base e is 2 times log of 10, because we can write this 100 as 10 square, and using the property of logarithm, the 2 will take in front of the log. Again f dash at a is 1 upon 100 is 0.01. So f of a plus h is approximately equal to f of a plus h f dash at a. Log of 100 plus 1 to the base e is approximately equal to 4.6052 plus 1 into 0.01. Now their multiplication is just only 0.01 and the addition gives us 4.6152. So this is the approximate value of the given function, log of 101 to the base e. Now the next example is f of x is equal to x cube minus 3x plus 5, and the point is given 1.99. So now we don't have to choose the function is already given and the point is also given. So what is the integer which is closer to 1.99? It is 2. So we take a is equal to 2 and h is minus 0.01. This is f of x. So what is the derivative? It is 3x square minus 3. Now the value of this f of x and f dash of x at x a is equal to 2. We have to find out. So f of a, put x is equal to 2. We get f of a is 7. Similarly, f dash at a is equal to 2 is 9. Then using the formula of approximation, f of a plus h is approximately equal to f of a plus h f dash at a. F of 2 minus 0.01 is approximately equal to 7 minus 0.01 into 9. So take their multiplication and now subtraction of 7 and 0.09. It is f of 1.99 is approximately equal to 6.9100. This is the approximate value of the given function. Now again we have to find the approximate value of log of 1016 to the base 10. Now here the base is 10, so we have to choose the function log of x to the base 10. But we have to keep in mind that the log of x to the base a, its derivative is 1 upon x log a, 1 upon x log a to the base e. But if I take this term to the numerator, I will write this log of 10 to the base e as log of e to the base 10 after using the reciprocal. It is also a law in the logarithm. So log of e to the base 10 upon x, but its value is already given 0.4343. So we have to write it here. Then a we have to take 1000 and h is 16. So this 1000 can be written as 10 cube. That cube is taken in front of this log. So 3 log of 10 to the base 10. Now we know that log of a to the base a is 1. So 3 into 1 is 3. So f dash at a is 0.4343 upon 1000, that is 0.0004343. So f of a plus h is approximately equal to f of a plus h f dash at a. So after putting those values in this formula and simplifying it, you get log of 1016 to the base 10 is approximately equal to 3.0069488. Now find the approximate value of f of x is equal to x cube plus 5x square minus 7x plus 10 at 1.12. Again here function is given and we can find its derivative. The point is given 1.12, so our a is 1 and h is 0.12. Take the values of this function at x is equal to 1 and the value of the derivative at x is equal to 1. Then use the formula to find the approximate value. F of a plus h is approximately equal to f of a plus h f dash at a. Okay, and put those values in this formula, you will get the final answer approximately 9.72. So the value of this function is at 1.12. If you put instead of x 1.12, you will finally reach at this answer 9.72 approximate value. Okay, so this is all about exercise 2.2 based on this approximation. Now we will stop here.